Here we are back in Geogebra again, and we have this same original shape that I made for the previous video, and this is its rotated version. And I moved that rotation center somewhere on this screen, and I made that rotation angle to be some angle, and then I hid them. And now we're going to try and figure out how to find that rotation center if you have the before and after picture, but you don't know where the center is. And for this, we're going to need a little fact about circles. So the fact we're going to need about circles is if you have 2 points on the edge of a circle and you find their perpendicular bisector. So we just finished doing some things with perpendicular bisectors. A perpendicular bisector goes through the midpoint of the segment and it's perpendicular to the segment. And the fact we need is that if these 2 points are on this circle, then that perpendicular bisector will always go through the center of the circle. Okay, so over here, somewhere there's a center of a circle. Maybe it's here. And then, maybe there's the center. And then on that circle, when I make these rotations, all of these rotation points live on a circle going around the center of rotation. So if the center of rotation is here, then A and A prime live on the same circle whose center is the center of rotation. And B prime live on the same circle that goes through the center of rotation. So what I need to do is I need to make some segments and then some perpendicular bisectors. So here's my first segment. It's going to go between A and the image of A. And let's do B and the image of B. So B maps to this point here. And now I need the perpendicular bisectors of both of those segments. So the center of rotation, wherever it is going to lie on perpendicular bisector under construct here. It is on the perpendicular bisector of the segment between A and A prime. And it is also on the perpendicular bisector between B and B prime. And I think we've just found it. Here is a center point. And so now you should be able to kind of see this. If I went around from that center point and I went around by some angle, I'm just going to draw the circle so to help you see this better. If I went around, I would go from A to A prime going along this circle. And let's see, B and B prime that's going to be a hard thing to, let me do D. And if I went from D to D prime, it would be going around on this center with this circle with the same center, and it would be going by the same angle. So the angle going from D to D prime, and the angle going from A to A prime, and the angle going from B to B prime should all be the same angle. So now I'm going to measure that angle. I'm going to undo a little bit because I don't think we need to see all of these circles. We just need the center of rotation. And so we're going to measure an angle. And I think I'll draw the angle first. Let's put in a couple of segments. So let's use A and A prime. So I'm going to rotate around center R from A to A prime. And so whatever angle this is, it's the angle that goes, it's this angle here. So now let's measure the angle. It's under measure, wherever measure is. measure, angle. So A to R to A prime. Oh, good. That went the direction I wanted it to be. That's a rotation of 108 degrees. So finding that angle at the end, knowing what to measure for the angle at the end is pretty easy because you just have to pick a starting point and an ending point, and that'll work for getting you your angle. And you don't have to pick A and A prime. If I picked C and C prime, I would get 108.808 degrees. I'd get the same angle. But what I do need to do is I need to figure out how to find that center of rotation. And for that, I need that fact about if you take a chord on a circle, if you take a segment between 2 points on a circle, then its perpendicular bisector will go through the center of that circle. And so if you take the perpendicular bisector of the segment between the start point and the end point after a rotation, that is going to, that perpendicular bisector is going to go through the center of rotation.